Hello! In today's tutorial we will use Concord to generate random variations of a given melody. To do this you can follow along by downloading the project at the link in the description and then opening up the content browser, and in the root folder you'll find the Hush model. And this is the Concord model that we'll use to generate our variations. When you open this up, you'll be greeted by 4 notes that are already given to you here in the graph. 2 of them are parameter notes, one for the melody and the other for the bass, which are given from this Hush crate, which is already loaded as a default crate for the model. But we also have 2 output notes that address 2 of the channels of our piano preview sound that I've loaded up here. When you press the spacebar or click on the sample variation button, the Concord model is run and new values are generated for our outputs. As we can see, our melody is given by MIDI note numbers and zeros, which are displayed as these dots. And zeros in Concord simply mean that no new note is played in that position. We can use the play button right here under preview and latest pattern sampled from editor to preview the sound. You will also have noticed that in our outputs we have some bars next to the numbers. These bars represent the shape of this output. In Concord, each connection represents a multidimensional array that travels from one node to the next. And these multidimensional arrays have certain shapes. For example, our melody is 4 by 4 by 2. And that's what these bars represent. We can press the spacebar again to sample another variation. But nothing changes, because we have not added any random behavior to this model yet. So let's get to it. The idea is to randomly remove some of the musical notes in our melody, so that we can generate variations. We will achieve this by using a mask, which will have zeros and ones for each quarter note segment of our melody. Whenever there is a 0, we will not output any notes in that position. And when there is a 1, we will pass on the melody as it is. To do this, I will right-click anywhere in the graph to create a new note, and then I will type box in the search bar to create a new box by pressing enter. I will name this mask, and now we can make some adjustments to this box. In Concord, boxes contain random variables, and you control the number of random variables that a box contains by setting its shape down here in the default shape tab of our details panel under box. We already have one dimension given as default and it's size 1. We will set this to size 4 and those will represent our 4 bars. We can then add another dimension to this box by clicking this plus button and then opening up the new index, and we will also set this to size 4 because we have 4 quarter notes for each bar. I will move this box out of the way. And now, when I press the spacebar, you will see that each one of these random variables, which are represented here by these pins, will get a new state value. Pressing the spacebar multiple times will sample different values for each one of these random variables. Right now, they follow a uniform distribution, meaning that each of the values that the random variable can take is just as likely as all the others. We can change the amount of different values each random variable can take using this state count down here. However, for our purposes, this state count of 2 is exactly correct, since we want either zeros or ones to fill out our mask. Now let's apply the mask to the melody. To do this, I will right-click anywhere on the graph and type if. Then press enter to create a new if node. An if node has a condition, a true and a false input, and if the condition is non-zero, the true branch will be chosen, otherwise the false branch. So now let's make the necessary connections. We'll use our mask as the condition by dragging off the all pin and connecting that to the condition input on the if. Then we'll use our melody whenever the mask is true, and we can leave the false branch as a simple default value of 0 to output no notes whenever the mask is false. Now let's alt-click on the output pin of our piano/notes:1 output to clear the connection. I'll drag this over here and make this new connection from the if node. Now let's press the spacebar and observe our results. As you can see, on the first random variable here we have a 0, so the first quarter note segment is zeroed out in our output melody. Let's take a listen. As you can see, we have punched some holes in our melody. However, there are certain places where the melody should really come through because otherwise it'll get unrecognizable. I would like to change the probability distribution of our mask so that in certain positions having a 1 there is much more likely than having a 0 there. Before I move on, I will just select all of these notes that pertain to the melody and move them to the side a little bit so that we have more room. And then I will add the necessary notes so that the third quarter note segment of each bar is much more likely to have a 1 in the mask than a 0. To do this, we first need to address the third quarter note segment in each bar. To do this, we can drag off the All pin and then simply release the left mouse button to add a new note and instantly make the connection. I will type get and press enter. The get node can be used to get a certain value along a dimension. We want to get a quarter note segment, and if you remember, we have set up our box to contain 4 bars by 4 quarter note segments. And in Concord, indices start at 0. So the dimension index 0 corresponds to the bars, and the dimension index 1 corresponds to the quarter note segments. In the get details, we can set the dimension index, and I'll set it to 1. And the index is also 0 based. So we have quarter note segment 0, 1, 2, and 3 in a bar. And we want to choose 2 right here to address the third segment within a bar. We can always drag off some of these output pins and create an output node to debug what we're doing. Next, we want to somehow tell the model that a 1 in these positions is more likely than a 0. In Concord, we can use scores to convey which configurations are likely. A higher score means the configuration is more likely. So we can simply multiply these values by some score multiplier and route that into a factor, and then having a 1 in that position will add to the score. So let's add the nodes so you can see what I'm talking about. First, I will delete this debugging output, then simply drag off the get node to create a multiply node. I will choose a value of 5 right here for the default value of the other operand, and then drag off the output and create a factor node. The factor node has just one input called score, and this will take care of making 1s in these positions more likely. If I press the spacebar, we can see that now the visualization of the entropy of the probability distribution of our random variables changes. Before, all of the random variables were red, meaning that they are uniformly distributed and everything is just as likely as everything else. Now every third quarter note segment in our bars is blue, meaning that one value is much more likely than all the others. And it's the value of 1. Let's reduce the score multiplier by a little bit to add a bit more variety. And you can see the color changes a bit towards red. And now, whenever there's a 1 on the third quarter note segment, there could also be a 0, it's just not as likely. We can visualize this by dragging off one of these individual random variable pins and typing viewer. Then when we press the spacebar again, we get a bar chart of the probability distribution showing that 1 is much more likely to happen 95 times out of 100. It'll be 1. Let's press the spacebar again to generate a new sample and take a listen to this. Until now, we have created variations by removing some of the notes from the input melody. Let's try something else. Let's try mixing 2 melodies together based on the mask that we already have, instead of just removing. So first, we will need to create a new melody to mix the original melody with, and I'll keep this quite simple. We will add a parameter node, and we call this melody 2. This parameter is of type int, so we can enter integers in the default values right here. Under parameter default values, I can click on the plus to get another value, and I will enter 71 and 69. Those are 2 of the note numbers that occur in our melody, and I will simply repeat these note numbers across our melody, and then we have a kind of very simple, very repetitive alternative melody to our input. To repeat these 2 values, I will simply drag off the parameter output pin here and type repeat. And then in the details under repeat shape, I will add another dimension and repeat these 2 values 4 by 4 times. So in the end, we have 4 bars by 4 quarter note segments, and each quarter note segment contains 2 eighth notes. as given by our parameter. Now we will use the output pin on our repeat node instead of the default value of 0 for our if. Then press the spacebar to generate a new variation, and let's take a listen. And just like that, we have generated a system that will generate variations based on 2 input melodies and mixing them based on a mask that has different probability distributions depending on the position of our quarter note segments. Let's generate one more sample. I encourage you to make changes to this model and come up with your own models that generate variations in a similar way to this one. You can try out different melodies for your mix-in melody, but you could also use the given melody and maybe reverse it, or try changing the pitches. For now, thank you for watching, have a nice day.